welcome. We're going to be talking about performance in the cloud. And this session is all about how Microsoft and the SharePoint and OneDrive engineering team thinks, architects, and builds performance or builds features and services with performance-first mindset. A quick introduction. My name is Shyam Narayan, and I am a principal program manager on the SharePoint and OneDrive engineering team focused on platform performance. I've spent more than a decade with SharePoint, the first half as a consultant working with customers, helping them build and deploy SharePoint. This is both on-premises and helping them transition to the cloud. And the last 5 on the core engineering team, helping build and operate the service. With me today is Akanksah Rakesh.
Good morning, everyone. I'm Akanksah Rakesh. I'm a program manager in the SharePoint Online infrastructure team. I've been a SharePoint user for more than 5 years now. But about a year ago, I joined Microsoft to work on SharePoint, and my main area of focus has been platform health and reliability.
Thanks, Akanksah. So Akanksah and I today are going to pop the hood on SharePoint Online and talk about how we engineer performance both across the breadth and depth of the service. We have a lot of demos lined up. Do you all like demos? Oh, that was not that good. Do you all like demos? OK. And these demos are really intended to tie together some of our architectural investments into real-world examples and real-world scenarios that you interact with on a daily basis. These are all live-wire performance demos, so I really hope the demo gods are smiling on us. And then towards the end of the session, we're going to wrap it up with talking about some of the learnings we have from the service and some of what we see with our customers that you can take home and apply to your own networks and own connectivity to get the best out of what we're going to show you today. So we're going to kick straight into a demo. How many of you attended the keynote this morning? Awesome. How great was it? A lot of cool announcements.
Yeah.
But there's one particular announcement around Fluid. How many of you know what Fluid is? OK, one hand over there. So Fluid is a web framework or runtime that Microsoft has developed, and we unveiled it about a couple of weeks ago at the Build conference. And what Fluid allows us to do is build these high-performance, multi-user, real-time collaborative scenarios. It's built for this large-scale collaboration scenario, and that's real-time. Today, we're going to show you a Fluid experience built on top of files stored in SharePoint and OneDrive. So I'm going to switch over to my demo machine. And a couple of things about this demo. We've set it up to really showcase all our investments. So I've got 2 browsers open here. On the left, it's me logged into my Office 365 tenancy. And I've got a document open that's backed by SharePoint and OneDrive. It's stored in Chicago. And what we've got doing is Akanksah is going to be joining me in co-authoring this document. And we actually have her logged into a virtual machine in Dublin, Ireland. Not only is she logged into a machine 5,000 miles away, she's also running this machine on Amazon's EC2 infrastructure. We are not running it on Azure. We want to make sure there's fair play. This is a performance demo, and we want to make sure we're doing this right. So she's going to be authoring the document logged into a machine 5,000 miles away, and I'm going to be co-authoring with her here from Vegas. So Akanksah, I shared the Contoso earnings document with you earlier this morning.
That's right.
Do you want to open that document and join me in authoring this document in front of all of us?
Absolutely.
So there you go. She's opened the document, and she's logged in as Emily. I'm just going to show you here. Click in. So she's logged in. I can see Emily has joined in, and I can see the presence markers show up in both windows. Now, what we want you to do is, as we type on our screens, we want you to watch both windows and see how content shows up instantly on both sides of the house. So I'm going to start first and start typing a introduction with typos, clearly. And what you see is, as I'm typing content here in Vegas, it's showing up instantly 5,000 miles away in Dublin, Ireland. Isn't that cool?
Yep.
I think this is 5,000 miles away. We're seeing things come instantly through. That's just a title. Let me go ahead and add some more content to the document. I promise I'm not going to write an entire document on stage. So I got some content copy-pasted. I'm going to add it in. And again, a whole bunch of text shows up instantly on the other side of the world. Now, I know Akanksah is very particular about formatting, and I can see her already in the document starting to edit it. You can see her select text. As she's selecting text in Dublin, it's getting highlighted on my window here in Vegas. She's starting to apply formatting to it, all in real time. And she's also selecting a lot of text, which doesn't look good.
I'm going to delete this text, Shyam, and add a table to summarize our content.
OK, so delete goes instantly as well. So I want to add a table in there. That's fine. There you go. Table shows up. The components of the document also showing up in real time.
Yep.
So wasn't that cool? Real-time collaboration across geographies in real time. Now, I want to stop here and actually talk about the mechanics of what's happening behind the scenes here. Every time Akanksah or me clicks a keystroke on one of our machines, we're sending it over to a server in North America. This is the SharePoint server in North America, where we have to store this content behind the scenes. And while we are relaying it over to the other user, in this case, Akanksah, across the Atlantic to Dublin, all in real time. And this really brings together all the investments we're going to be talking to you about. So how cool was Fluid running on top of SharePoint? Awesome. So I'm going to switch back to the slides. So Fluid is one experience that leverages SharePoint and OneDrive behind the scenes. But we have a lot of other scenarios, such as the modern team sites, portals on the web, through to Office, Sync, and Teams on the desktop. And our goal is to provide great end-to-end performance across all these modalities. Right? And to do that, we've been making foundational investments across 3 broad pillars of networking, storage, and the applications themselves. We're going to be spending the rest of the session digging into each of these pillars and walking you through our investments across all of them. Let's kick things off with networking. Now, when we think about networking, it isn't about just how our servers are doing. We fundamentally believe for us to provide a great end-user experience, we need to make sure the connectivity from the end-user's machine all the way out to our servers is great. And to do that, we actually break the network out into these 3 broad segments. We start with what we call as the first mile. You can think of first mile as the servers, network infrastructure, global data centers that Microsoft runs and operates in more than 54 regions today. This is where we have the most control because it's code and infrastructure we own and operate. Stepping out, we have what we call as the middle mile. This is where we have ISPs and network service providers actually plugging into the Microsoft network. We have to go optimize that as well. And then finally, out in the wild, we have what we call as the last mile, which is end-user connectivity into Microsoft. And this is often the most challenging space because we are now dealing with corporate networks, home networks, people on their mobile devices. But we believe to provide a great experience, we have to optimize connectivity across all these segments. Let's start off with first mile. Here, I want to let you in on an engineering challenge we faced in the SharePoint Online team. So SharePoint is a very unique workload where we have a mix of scenarios running. You saw this morning, we announced home sites through to Fluid. But in the real world, when we look at our networking traffic, we get this varied mix of networking traffic coming through. We have small files. We have large files, web traffic. We also have video streaming going on. And when all of these traffic land on our boxes at scale, we used to run into a couple of networking bottlenecks. Instead of getting into all the detail, you can say that you can think of our networks looked something like this, where we had a whole bunch of networking traffic line up on the box, and either they would go slowly or they would get stuck. And this wasn't a capacity problem. It was a traffic mix problem. So what we did, we actually rolled our own custom networking driver to smartly aggregate this networking traffic to make it look like this, where we could keep traffic going at high speeds, even under load. And the key thing over here is we optimized our network for the SharePoint Online workload. Clicker stopped working. Not only did we roll our own driver to optimize our traffic, we also worked with our network interface providers. These are third parties building our hardware, and we actually worked with them to optimize the settings on our boxes and our network interfaces to suit the SharePoint Online workload. This required a lot of experimentation, a lot of going and back and forth with different engineering teams to get that right for the SharePoint workload. We run on virtualized infrastructure. We wanted to make sure all our physical investments we made in our physical servers came through directly to our virtual machines without having any of the virtualization overhead. So we leverage a technology called as SRIOV, or single root IO virtualization, which allows us to directly map these physical network cards into our virtual machines running Windows. So it's not a surprise, we run SharePoint on top of Windows, and we've done so for a long time. But there are a couple of deep investments we've made in the Windows space that I wanted to talk to you about. How many of you like TCP or TCP/IP? Well, not a single hand? Oh, the one hand, OK. So TCP/IP is fundamentally the reason we have the internet today. But a lot of these protocols were built for networks that were designed probably for 30 or 40 years ago. And they were pretty much built to make sure, and these protocols were built to make sure that we don't take down the network. If there are a lot of users trying to send data, we wanted to make sure the network was protected. And I think the protocols have done a great job, given the fact we still have the internet up and running. But what we did, we run a lot of our own infrastructure on the back end, which is built with fiber optic cables connecting our data center with a lot of bandwidth and a lot of capacity. Transient issues on our network isn't related to a capacity or networking shortage problem. So what we did, we worked with the Windows team to bring innovations into the TCP layer. There is a more nuanced or more adapted congestion control protocol called as TCP/Cubic, which has been available in Linux kernels for a while. We brought it to Windows. And it allows us to take the full advantage of the Microsoft network. We're investing in these, what you can think of as long, fat pipes. We want to make sure we're able to fill it and take full advantage of it. So that's what TCP/Cubic gives us. We shipped it as well as part of the fall creators update. So Windows, if you're using Windows, you'll actually get this built into your operating system. Not only did we stop there, we also went and selected the right set of cipher suites because we have to encrypt and decrypt content. We are extremely security sensitive. We want to make sure that any content coming into our boxes or leaving is encrypted. But encryption does have overhead, because we have to go through the content, encrypt it and decrypt it. There is definite overhead over there. So we use a cipher suite called as GCM, which takes advantage of the modern microprocessors to really reduce the overhead of encryption. We're able to do the same work in much faster time. We run on top of IIS and ASP.NET. We work with those teams within Microsoft to get a whole bunch of optimizations for the SharePoint workload, all the way through to SharePoint. We announced a lot of cool features in SharePoint today, but there's one which is very specific to our topic of networking. We have built capability into the SharePoint Online product where on a per request basis, or every request coming in, we are able to understand what's happening underneath the hood on the network. So think of it. We are now able to map the network state all the way from our servers out to the end user's machine. And we can figure out what's going on the network. If a request was slow, was it because SharePoint was slow? Then we would go fix our code. Or if it was the network, where on the network? Was it on the Microsoft network? Was it congestion on our side, or was it on the internet? So this allows us to get a Hawkeye's view into the network and go troubleshoot it. And then finally, those are all done to SharePoint infrastructure. We run in a broader ecosystem across the Microsoft infrastructure using Azure and a whole bunch of other services within Microsoft. We wanted to make sure that all networking devices and proxies and edge devices that SharePoint Online traffic transits through is also optimized for SharePoint Online. So we spent a bunch of time optimizing the network devices all the way out to the edge of our network. So the quick summary here is SharePoint Online workload is very specific, and Microsoft and the SharePoint Online engineering team have spent a lot of time tuning our first mile for this workload. Stepping into the middle mile. So middle mile is all about how ISPs and network service providers connect into the Microsoft network. And the goal here is very simple. We want to make sure that traffic that's bound for SharePoint Online and OneDrive for Business gets into the Microsoft network as soon as possible so we can take advantage of all the first mile investments we've made. So here we have teams dedicated within Microsoft that spend a whole bunch of time with our network service providers and ISPs in making sure that they're peering correctly with the Microsoft network. Peering is nothing but how we agree on sending traffic into the Microsoft network. And you would go, why is this important, right? We've had cases, as an example, we had a scenario a couple of years ago, I believe, in the Asia Pacific region where a certain ISP wasn't peering correctly with Microsoft. And all our customers who use that ISP to talk to our service had degraded performance. So we had to go work with this ISP to make sure those routes are optimized and they're sending traffic that's bound to the Microsoft network as soon as possible. We don't want it hanging around in the ISP network because we lose the opportunity to accelerate it or optimize it. So those were quick, that was a quick lap around first and middle mile investments. I'm now going to hand it over to Akanksah, who's going to talk to us about how we have optimized end user connectivity in the last mile.
Thank you, Shyam. So before I take you through our last mile investments, let us go back in time and see how the users connected to SharePoint Online. When you or your administrators signed up for Office 365, we placed your content in a pair of data centers within the Microsoft network. Now, if the users, in this case Betty, wanted to access her content, she would have to traverse through multiple networks. First, her own managed corporate network, then the unmanaged internet, and then finally the Microsoft network, where all the optimizations within the data center networking that Shyam just talked about have been made. But there's a problem with this model. The users ended up spending a significant portion of their time in the highly congested and likely unreliable unmanaged internet, and that directly impacted performance. In the last year, we have changed this experience through our last mile investments. Let's dig a little deeper into that. Now, SharePoint Online and Office OneDrive for Business comprise of multiple data centers. We currently have about 54 data centers deployed globally. These data centers are wrapped in what we call as Microsoft Global Network. Microsoft Global Network is one of the largest wide area network on the planet and is fully managed and operated by teams within Microsoft. The wide expanse of this network allows us to place edge nodes on the periphery of the network. In case of SharePoint Online, these edge nodes are called Azure Front Door nodes. Think of Azure Front Door nodes as the closest piece of Microsoft infrastructure to our users. And the primary job is to get the traffic onboarded to the Microsoft network. We have these Azure Front Door nodes deployed globally, strategically located in key cities. And they are interconnected with multiple thousands of internet service providers. The connection between these edge nodes and the internet service providers is what Shyam talked about in the middle mile investments. Not just that, these edge nodes and our data centers are also all connected with each other through high bandwidth and low latency data center networking that he just talked about in the first mile investments. Now let's just see how Azure Front Door node routes our traffic in case of real life scenario. Let's assume our user Betty is on the West Coast in San Francisco and wants to access her content, which is hosted in a data center in Chicago. Now, earlier, Betty would have to make this long-haul connection across the country on traditional internet. But now, she will connect to the closest Azure Front Door node through our state-of-the-art Anycast routing. And at this point, her request is on the Microsoft network, which will accelerate the connection between Betty and the Chicago data center. Now, let's also assume Betty wants to collaborate on a document with another user, Veronica, who is in Sydney, Australia. Now, you can only imagine the quality and performance of a connection made over the Pacific using unmanaged internet. But instead, Veronica will connect to her closest front door node. In this case, we have one in Sydney, Australia. Hop onto the Microsoft network, which is pre-existing, pre-warmed, and that will accelerate the connection between Veronica and our Chicago data center. The key point to note here is the performance gain comes from reducing the time the user spends on the unmanaged internet. Instead, we do all the heavy lifting behind the scenes on the Microsoft network that takes advantage of the first mile, middle mile, and last mile investments that we just talked about. Let's see Azure Front Door Node in action. So here what I'm going to show you is the experience of a user trying to download a document from two tenants. One tenant uses Azure Front Door Node, and the other that does not. I'm logged into a remote desktop that is hosted in Sydney. I have two tenants here, the contents hosted in North America. On the left, the tenant that you see is using Azure Front Door Node, whereas on the right, we have a tenant that is not using it. Now, before I start downloading, let's just do a quick ping test to see what the network connectivity of these two tenants looks like. So I'll start pinging the tenant that does not have Azure Front Door Nodes, and let's see how that performs. On an average, you can see that this tenant took about 198 milliseconds for the network connection. Is there a difference between the tenant that uses Azure Front Door Node? Let's see, and what does the difference looks like? There you go, 3 milliseconds. That's a huge difference, almost 70 times the improvement in network connectivity. Now that is, again, network metrics. Let's go and see how the user experience looks like. So I'll download a document, again, from a tenant that does not use Azure Front Door Nodes. The download must have started now, and I'll do the same. Is it?
You get it going.
Where is it? Let me see again.
Like I said, these are live wire performance demos. They are not cooked. Showing it to you in the real world example. So there you go. Finally, we got it going.
I'll do this again just so that you can see the difference between Azure Front Door Node and the one that does not use it. Let's cancel it again.
So I think the key thing, while she resets for the demo, the key thing over here is routing without Azure Front Door results in taking a longer route out to SharePoint. And you end up spending a significant amount of your time traversing the internet. Whereas in this case, going through Azure Front Door, we hit the Sydney node, terminate the end user connection in Sydney, and then we're able to blast the traffic over our backbone. That's what we want to show you as a example today of how end user experiences get accelerated and improved using Azure Front Door and our edge routing technology. Hopefully, we can get it going.
Yeah, let's see again. I've started in the side that does not use Azure Front Door Node.
It's going fast.
I think this is. There you go.
And what you will see over here is the one that's not using Azure Front Door starts up fast, but as soon as it hits congestion or probably a network hiccup, it's going to slow down a lot. Whereas the one that's routing through Front Door keeps going because it's able to recover from any congestive loss on the network and keep the user experience up.
There was a lot of talking that we did, and the one that does not use Azure Front Door Node, it's still going on.
Yep.
At 2.2 megabyte per second, whereas the other one took, on an average, 50 megabytes per second. Again, a huge difference. That's a stark difference in user experience. And what did you see here? The user that is accessing both the tenants is in Sydney. Both the tenants have contents hosted in North America. Yep. The only difference, one tenant with superior performance experience is using Azure Front Door Node, whereas the other is not. So it does not matter where the user is located. With our optimized networking stack, we are able to provide a consistent performance experience to all our users, regardless of the location they are located in.
Awesome. Thanks, Akanksah. That's pretty awesome. Like, we downloaded at 50 megabytes per second from Australia coming out to the US. I think that deserves another round of applause, right? Thank you.
Yeah.
So that was coming through, showing our last mile investments. Now, I want to move on. So before that, just a quick recap. This is a take-home slide that we keep getting asked about. Where are your node locations and how are they connected? So this is a take-home slide for you. But the key takeaway from a networking perspective is we have optimized all segments of our network, starting with the Microsoft First Mile, which has been tuned for the SharePoint Online and OneDrive workload. We partner closely with thousands and thousands of ISPs and interconnected more than 200 locations globally to take this ISP traffic into the Microsoft network. And then finally, we have shortened the last mile by getting closer to end users with Azure Front Door and our routing technology, and really shift the heavy lifting onto the Microsoft network. Now, all the networking space is about moving data around or moving the bits around. But what about the bits themselves? So I'm now going to switch gears and talk about our optimizations in our storage tier that allows us to build really performant experiences. And we're going to cover two aspects. One, physically how we store and retrieve data from our backend tiers. And two, how we actually interact with the data in our applications. And to do that, I'm going to start walking through a normal upload scenario. What does it take when Betty tries to upload a file? So when Betty uploads a file, I've simplified it, the file contents come up to SharePoint Online. And the first thing we do once we have the file content is actually take the file and split it into multiple smaller chunks. Then we take each of those chunks and actually encrypt them with a unique key. We take a large file, we split it into multiple pieces, and each of those pieces get encrypted with a unique key. And again, the encryption now is taking advantage of the GCM capabilities we've built into Windows. Now, on the back end, SharePoint and OneDrive leverages Azure Storage or Azure Blob Storage to back our data tier. We run our storage tier in what we call as an active-active setup. And what this means is every time you upload content to us, we actually write it out to two geo-redundant Azure regions within the geo boundaries. So let's assume you have decided to store your content in North America. We will write it out to two different Azure regions for geo-redundancy. Not only do we write it out to two regions, when needed, we also read data from it in case to provide high availability and performance. Now, the files are chunked and ready to be stored. We have also optimized how we write this data out to our backend. So what we do is, instead of writing it out serially, we actually blast the data out to both regions, all those chunks in parallel. And that allows us to basically make up for any large files. If there are large files, what we do, we just have a lot more chunks, and all of those chunks are going out to the backend Azure space in parallel. So we're able to really reduce the time it takes to save files in our backend. When both the regions come back and say, yep, we are good to go, we do a whole bunch of signature checks and tell the user we have your file. All of this is happening at extremely high speeds. That's upload. What happens when we're downloading the document? And things get slightly different, but we use the same principles. Let's assume Betty wants the same file back. And what we do here is SharePoint Online has what we call as a preferred region where it goes to get its Azure data from. Generally, it's closer to the actual data center hosting our compute tiers. So we reach out to that Azure region and start reading those chunks back. In this case, 2 of the 3 chunks have come back, but the third one's taking slightly longer. And this is completely expected. We are a large distributed service with millions of requests coming through, and we expect and design for such latencies. So we've built in mechanism into SharePoint Online, into our storage tier, which tracks these latencies, and we've set thresholds. When some of these backend fetches are taking longer than expected, we automatically go to the secondary region, read out the chunk, and assemble document for you, and send it back to the end user. Isn't that cool? Like, we are doing all of these things behind the scenes, and the end user and applications are completely unaware of these underlying mechanics. Now, when you think about it, end users are frankly not concerned about what's happening under the hood. It's all cool tech. But what they are concerned about is their files and the contents of their files. Let's say you have a PowerPoint document, and a standard interaction goes where you launch your PowerPoint application on your desktop or on the web, open up the file. And once you've opened up the file, you generally don't think about the file. You think about the contents of the file. That's where you work with. We work with contents of the files. In this case, it could be slides. You're adding slides, deleting slides, or moving things around, adding content in, or dropping a whole bunch of images. That's where end users spend most of their time interacting with our files. Wouldn't it be great if a storage tier could understand these components to help build really cool and innovative scenarios? So that's exactly what we have done. We have revamped our storage platform underneath the hood to understand components or parts of the document to build scenarios like differential sync that we showed off during our keynote today. Let's take slide 4 as an example here and click into what that looks like. What is our storage tier doing underneath the hood? So here's a typical slide. Right? It's made up of text. It's made up of a bunch of images that have been composed together. What we now do is in our storage tier that's built on Azure, we represent the document in a data structure called as a B tree that allows us to understand and go through parts of the document similar to what end users would do. So if you take a PowerPoint document, we would say, hey, it's made of a bunch of slides. There is slide 4 in there. So we can go ask our storage systems to say, tell me what's in slide 4. Not only do we know how to read through different slides or any content, we can also click into what's on those slides. We can say, hey, just give me those images on those slides, or tell me what text is on those slides. And what this allows us to do, being able to essentially seek across documents and get into targeted components within the documents, we're able to operate on files regardless of their size. So that's what we have done behind the scenes in interacting with our documents. Let's look at differential sync that actually leverages our storage tier to provide the scenario. So how many of you attended the keynote and liked the differential sync announcement? A few hands, OK. So what is differential sync? Today, if you are using OneDrive and SharePoint, let's assume you have a document library with lots of content in it, lots of images, lots of PDF documents, or even video, and you're syncing that library down to your machine. You open up one of those PDF files and make an edit on it. What's going to happen is we're going to send up the entire content back up to the server. Let's assume it's a 40 meg document. Every edit you make, we end up sending the entire content back up to the server. That's today. With differential sync, what we're able to do is reason over that change more locally. We're like, hey, what is the actual change in the document? And only send the changes back up to the server. This significantly reduces the amount of network traffic we are sending back and forth. And also, when working with large files, it shortens and reduces the amount of time for you to get into a good sync state, improving performance. I'm going to switch over to my demo machine here and show you differential sync in action. I have a document library that I'm syncing down. It's got a bunch of images in it. If I open it up, you can see it's locally synced down. I also have Fiddler running behind the scenes to capture some of the network traffic. I'm just going to clean this up so we can look at fresh traffic coming in. So this has got a bunch of JPEG files and a bitmap file in it. I'm going to open up the JPEG files and set some properties on it. Now, JPEG's a weird file format because you can set properties on files, which gets demoted into the file itself and moves around with the file. So when we change some of these properties, we actually have to update the file on our server. If you can look here, it's about 138 megs for all of these JPEG files. And without differential sync, a change like changing the property of rating would end up uploading all 138 megs back up to the server. We have differential sync running, so I'm running a preview build of the sync client with differential sync enabled. I'm going to go ahead and hit OK. The sync client should start processing these changes behind the scenes. And you would notice instead of sending the entire content up, it's just sending up tiny differences back up to the server. It's hard to figure out what's going on over here. This is just the end user experience, and that's why I have Fiddler attached to capture the network traffic behind the scene, what's happening on the network. If I click through one of these requests and actually click in, you'll actually see I'm showing you the under the hood stuff here, so bear with me. This is basically resulting in what we call as an inline diff scenario, diff upload scenario, where we figured out the change in those documents and only sending up the change. If I go look at the statistics, which is telling me how much content I sent up, so there was probably 33 kilobytes sent up for that single file. Without diff sync, I would have sent up like 20 megs or whatever. We're reducing that to 33 kilobytes in this case. So that's PDF files. Let's get a bit more serious over here. I also have a monstrous bitmap file on my machine. It's 1.1 gig in size. And I'm going to open this up in my favorite graphics editing tool, Paint. Let's see how that stacks up. It takes a while. This is a 1.1 gig file opening up. Give it a few seconds. The Paint has to go render out these documents so we can render out the bitmap so we can actually go interact with it. It takes a couple of minutes, unfortunately. But once it comes up, what we're going to go do is edit some of this content and see what happens. And this is a fairly common scenario. If you're using something like Photoshop, editing images, or using video editing software to edit your videos, we would end up syncing the entire content. With diff sync, just those deltas go up. Yes, SPC is the best. I agree with that. I think Jason put it in this morning. So I'm going to go in there and make my own addition to the bitmap. I'm just going to go in there and add a nice oval, hit save. It's going to take a few seconds for the save to run complete because we have to write the file out to the disk. And you can see Paint is not responding, but it'll come back. Trust me, I've tried this a few times. There you go. And I can see the sync lines now starting to process the content. It's going to take a while for the sync line to just figure out what's going on. And this is important because we are now trying to reconcile what we have on our local machine with what we have on the server to make sure we're able to send across as narrow a piece of data back up to the server. Right? We want to make sure when we get the file into a consistent state on the back end, it's exactly how you wanted it to be. You could also have other colleagues of yours interacting with the same document and updating it. So we want to make sure we don't overwrite those changes. So in this case, you can see sync line's done uploading the changes back up to a server. There was a 1.1 gig file that I edited, and it got uploaded in under 7 seconds. If I go back into Fiddler, and I believe it would be that traffic, if I click through, again, you can see that it's done a diff upload. The raw contents over here at the bottom of my screen that I've got highlighted is actually the binary delta that we're sending up to the server. So we figured out from that 1.1 gig, what is the delta ranges I need to send back up to the server so I can merge it back in. And if I go into statistics, it's about just around 6 meg that I sent over instead of the whole 1.1 gig. So isn't that cool? Like. Yeah. I'm going to quickly summarize and then hand over back to Akanksah. So that was our storage investments. We've optimized both the physical retrieval and storage of our data talking to Azure on the back end, and also built a smart and intelligent application layer in SharePoint Online that's able to reason over files. We spoke about PowerPoint upfront in our talk, but we can reason over any files. In this case, we were editing bitmaps and JPEG files, which are binary data. But we're able to reason over those files and build scenarios like differential sync that takes advantage of our storage investments. I'm now going to throw it back to Akanksah to walk us through our application investments.
Thank you, Shyam. So you saw we have made a lot of improvements in our networking and storage to really build up for performance at a global scale. But early on in our performance journey, we realized that in order to give the users a great end-to-end experience, it was important for us to bring our client applications, such as Sync, Team, or Office, along with us on this journey. So let me quickly take you through some optimizations that we have done on our client apps. There are essentially two significant changes that we have made to our client apps. Our client apps are now optimized to use modern APIs. One such example of a modern API would be a streaming API that currently our Web UX, Sync, and Team clients all use. Now, if you're wondering what is a streaming API, think of YouTube, where if you want to watch a video, you don't wait for the entire video to buffer up before you start watching. Instead, the video starts playing while it is also buffering the content behind the scene. We have built a similar data streaming API, where if you want to download a large file, you don't have to wait for the entire file to be read and processed in the backend, and then transferred over to the network before it is available to your machine. Instead, As the file starts reading and processing, the streaming API starts pipelining the content to your machine. And this significantly eliminates any latency with file transfer. And then there is a built-in resiliency as well. We talked about file downloads. Now, if you're uploading a huge file, and for some reason file upload fails, we don't restart file upload from scratch. We have built capability where we resume a file upload from the point of failure. Now, all we talked about in modern APIs was how to get the bits faster to your machine. But when it comes to end users like you, real life scenario, let's take Office, for example, where you probably spend a lot of time. These are the scenarios that really matter. Scenarios like file open. How much time did it take for the file to open? Or how much time did it take for the file to save? Or whether there is a difference between a large file and a small file. So our second set of optimizations are towards these scenarios. We have worked with our Office teams to optimize these scenarios, make improvements to these scenarios across Office endpoints. In fact, we have built Office web apps from ground up, keeping performance in mind and making sure file open, edit, and save scenarios are performant at a large scale. Let me show this to you. So what I'm going to show you here is an experience of file opening of two different files, one which is a fairly large file and one which is a small file. So I'll go to a tenant, and I'll start with a Word file that is 27 kilobyte, and let's see how long does it take to open. Very fast, within a second. I know what you're thinking.
Yeah,
you're probably saying,
I think, again, that took literally under a second to open up. And we're straight in edit mode.
Yeah.
Like, I think that deserves first a round of applause before we move forward. Right?
But yeah, you're also thinking, well, it was a 27 kilobyte file.
Exactly.
Anything above a second would be embarrassing, and I agree. But what I really want to see is how does a 500 megabyte file, almost 20 times larger, how much time does that take to open?
Are you going to open it up on stage?
Yes.
OK, so you're going to open up a 500 meg PowerPoint file on stage.
Yes.
I probably think we need a bit more of audience participation for this. Do you want them counting down?
Yes.
Counting you down.
Let's do it, guys.
OK.
3,
so let's count down. Let's go. 3, 2, 1, and she'll open the document. Can we start? Let's go. 3, 2, 1.
There you go. In edit mode. Approximately the same time that a file 27 kilobyte took, the same time 500 megabyte took, 20 times larger. Now, the reason we are able to provide a consistent performance across these varied file sizes is because of the optimizations we made in the client app. We built new API and protocol that this client app currently uses. And on top of that, it's also using our storage optimizations and our network optimizations that we just talked about. That's incredible, isn't it?
Awesome. So I'm going to switch back up and just keep doing a time check. So it was a quick lap across all our 3 investment pillars, and I want to summarize what we covered today. We started off with our networking pillar, where we've optimized our first, middle, and last mile for SharePoint Online traffic. And we've done this for our global user base. No matter where you are, using our optimized routing, you will be able to get consistent performance. We have revamped our storage tier, both from a physical data retrieval and access perspective, and also how we interact with this data. And then finally, we've brought everything together by building modern APIs and protocols that take advantage of our storage and networking investments and bubble them up to the applications. And then we've updated our applications both on the web and on the desktop to take advantage of these investments, to really provide end-to-end experiences, great performing end-to-end experiences. So that was an overview of what we have done. You've got 15 minutes, and I want to leave you with what I would call as an action plan or a call to action when you go back to your work and your homes next week. So everything we showed you today is available. This is real-life production environments we are using. But we want to make sure that for you to take advantage of this, you need to be connecting to us in an optimal manner. We work very closely, both Akanksah and I work very closely with our support teams, review a lot of our telemetry, work with a lot of our customers, and we notice and we see that a lot of our customers are not connecting to Office 365 and SharePoint Online in an optimal way. And what we have done is we've looked at it across Office 365 and bubbled up a standard set of connectivity principles that you can apply to your organizations to take advantage of everything we've shown you. Right? These are generalized across all Microsoft services. So following these connectivity principles will help you not only improve your SharePoint and OneDrive experience, but also your Teams, Exchange, and your other video scenarios, like such as Stream. And what we have done, we've got 4 principles that we want you to follow, beginning with what we call as optimizing your networks for Office 365 traffic. And what we mean here is we want you to identify traffic that's bound for Office 365 and give it preferential treatment on your network. What we see, unfortunately, in many cases is traffic that's bound for your normal internet search or your social media websites, and Office 365 traffic are taking the same path out to the internet, which might be going through a bottlenecked proxy or isn't built for daily business use. What we've done, we've actually broken down all of our endpoints and categorized it into an optimized set, which is the core set of URLs we want you to treat preferentially. For SharePoint and OneDrive, it's 2 URLs and a bunch of IP addresses that we want you to treat preferentially. So if your network administrator or your security folks are concerned about opening your organizations up to all of Office 365, start with these few IPs and URLs, which make up, frankly, nearly 90 or 95% of your Office 365 traffic. So start there and then go broader. The second thing we want you to do is what we call as enable local egress. Right? It's just a fancy name for send your traffic out to the internet as soon as possible. What we notice in many cases, again, working with some of our large organizations is, especially organizations that have got multiple branch offices in different countries, we see that a lot of their remote branch office traffic gets centralized or routed back to a central location. Let's assume the company is headquartered in North America, and we have users in Japan. We notice that their traffic from Japan gets routed all the way back to North America on the organization's network, and they come out to the internet. Just doing that takes away all the advantage that we showed you today. We want that traffic to come out to the internet in Japan, and we have a front door node waiting to take that traffic and blast it over to the North American data center. Right? A lot of our customers who we have worked with were hesitant when we told them to do this, but every one of them we have done this with has only seen positive results. So please do try this when you go back. The other thing is also a similar play on latency, where we want you to limit the amount of latency before you get out to the internet onto our front door nodes. In many cases, people are doing the right thing, but they end up circling or hairpinning within their own networks before they get out to the internet. They're going through various pack files, which are sending them through various routes, and they end up spending a lot of their time on the internal corporate networks. We cannot optimize your traffic if you don't have it. So we want you to make sure, reduce the amount of time you spend on your internal networks and get that traffic out to the internet. And then finally, and I'm pretty sure a lot of folks would be in this boat, is we notice that end customers are actually breaking and inspecting our SSL traffic for security. I think about 10 years ago, if you were doing this for web traffic, such as your social media sites, or even off late your malware, you were trying to protect users against your malware. But doing it against SharePoint Online and OneDrive for Business, this is your trusted tenant, this is your content, makes no sense. Additionally, we showed you some of the binary data we are sending over the wire that's encrypted. It's highly unlikely any tool in between can actually reason over that content to actually provide you accurate, appropriate protection. So what we would prefer, and we would suggest, highly recommend, is not break and inspect our traffic. Instead, send it out to the internet and leverage the features in our product to provide you with the security and compliance requirements. We've got a ton of features that go over DLP, anonymous sharing, tenant restrictions that allows you to restrict access to your content and who accesses it, how it gets accessed, conditional access policy, which are built into the product with performance in mind. We would recommend that you use that rather than using something in between to break and inspect our traffic. We've got all of this content written up in detail at the URL on the screen. I would recommend you going back next week to your organization, sitting down with your network administrators, or if there are network administrators in this room, sitting down with your security administrators and walking them through this. Start small with the optimized set, which is a couple of URLs, and you'll immediately see the difference in performance. Yep. So with that, thank you for coming to this session, and we're going to open it up to questions for the next 10 minutes.
Thank you.